Okay, back on the SuperCube 3 that will not power up. At least it will not light the LED right there. So let's go ahead and push this out of the way. So I went ahead and printed up a couple schematics on this unit. Let me get this in the view where you can see it here in a pointing device. And so there is an optical isolator right here that goes between what they call the safety side and the line side, because this is not isolated. There are a couple of small standby transformers, but the main power amplifier is tied to the AC line. There's no transformer to isolate that. So as you can see, it says speaker relay right there, and I labeled that P32V because I did some ohm measurements to this connector right here that says 2 power amplifiers. So this is the low level circuit, and it says speaker relay is pin 5 and pin 4 is P32V. So let's go ahead and drag this out, and we'll set it about right there. And I will get an ohm meter that has pointy little tiny probes on it. And we'll just try to shove the pencil under that. There we go. Okay, I'm going to put this in ohms. And so according to the schematic, so remember, pin 5 is speaker relay, pin 4 is P32V. So if I go from P32V, which would be pin 4 right there, and I should get continuity to one of these pins, and I do, 0.2 ohms. This is the optical isolator right there. So I get 0.2 ohms. Now it shows that there is a 2.74K resistor to what's called speaker relay, and we know that speaker relay is pin 5. So theoretically, I should be able to go from that pin, and I get 2.72, which is close enough right there. And I know there should be a 47K plus the 2.7, so about 49K between pins 4 and pin 5. And look at that, it gets exactly 50K, perfectly fine. So at least I know the optical isolator is good. Now, let me show you why I'm diving down this rabbit hole. So this is the low-level board. So here is the LED that lights up on the board when the power is turned on. And it comes from that negative speaker relay terminal, and then this 2N3904 transistor right there drives it to ground when it gets the power on command through this R114 and Q8. So what I need to do is basically I just want to look and see, do I have my 32 volts on pin 4? What do I have on pin 5? Yeah, this schematic is so hard to trace because so many things are mislabeled or unlabeled. It's unbelievable that this thing ever made it to production. But when they work excellent. So let's get some things hooked up. I will be right back. Okay, so I thought I would go ahead and power this thing on. It is powered up. I do have my voltmeter connected to the chassis ground, which is this aluminum heatsink, but it's really just for isolation. There's no heat generated over there. And so I'm going to go ahead and check pin 4 and pin 5 of the connector as it mates to the main board. And let me get the schematic out. So I'm going to be looking for 32 volts on pin 4, and then just a bit less than 32 on pin 3 when this thing is powered, I'm sorry, on pin 5 when this thing is powered down. So there's pin 4, and I get 32.99 volts. This should be slightly less because it's not being commanded to turn on at this time. So if I were to get maybe a volt or two right here, I would know that it's being commanded to turn the power amplifier on, and then the LED should light because it is in series with this optical isolator right there. So moving on, I have this schematic right here, and then there is the reset command. There is the power on command. I'm not really concerned with reset because it resets this chip and there's not really much to it, but I am concerned with the power on command right there. And it's a NAND gate, negative AND, which is what that little dot is right there. And what that means is if this is positive and this is positive, then this will be negative because it inverts it. Well, negative. So if this is negative, this will be positive. Now, in an AND gate, these two have to match. So either both negative or both positive. So if one's positive and one's negative, it's assumed the input is still negative. This will be positive. So looking at it's pin 8 and pin 9 right here of U10C. And so I want to see both of those either being low or both high. And then let's get something up so I can move that out of the way. The chip is actually located right there. So if I measure pin 8, I get 13.04 volts. And if I measure pin 9, I get 0. So it's assumed the input is 0. The output should be 1 or high. And that's going to be on pin 10. So 8, 9, 10. And the output is low. Wait a minute, high, low, for a low output. It should be a high output. So I've got low, high, so it's assumed the input is low. They're both not AND, so it's a 0, and then that inverts it to a 1, so I should have a power on command. Interesting. I'm going to kill the power to this thing for just a moment. And I'm going to power it back on. And while it's in the power up stage, I just want to measure the 2 pins. So I've got, if I can get on it, hello, 13 and still 0. And pin 10 is still 0. Well, let's go ahead and look at pin 14, which is the 15 volt source into this unit. And I've got 13.03 volts, perfectly fine. Although it says it should be 15, I don't think the 2 volt deviance is going to cause any issues. Okay, so luckily I have another SuperCube that I'm working on. This is a SuperCube 2 right there. And so I've got it connected to the SuperCube 3 amplifier. I do have a dummy load connected, 16 ohms at this time. And sorry I bumped the microphone. I'm just going to go ahead and power this thing on. I do have audio going into it, I'm pretty sure. And yes, there is audio going into it. So let's power this on. And I'll bring the voltmeter over here where you might be able to see it. We'll measure the voltage on the 32 volt, which is 23. I actually have the voltage turned down just a little bit. And then on speaker relay, I have 24 volts. I did turn it up very slightly to see if it would power on. So if this does successfully power on, this voltage should pull down to 0. And there it did power on, 3.2 volts. And there's still something going on with this board, but it does power on, and I do get a red LED. And so that's kind of what I wanted to find out. Do I have an amplifier problem, or do I have a preamp? And I know for sure I have a preamp problem at this point. So this other driver board is having some kind of an issue because I hear humming coming out of this at this point, and it's clicking basically on and off like it's going into shutdown. So there might be a power amp problem with this. I'm not sure. It does show that it is successfully powered up. And do I have any audio over here? I have 0.776 volts. This should be the digital audio stream going into the amplifier at this point. I guess I should hook a scope up and look at it and see if I'm getting digital audio into the board. So I shut the power off there. I'll drag the scope out. We'll hook it up and see what it has to say. Okay, so there is the data input to the amplifier, and it looks pretty good. And watch this as I turn the volume up. And I do hear distortion coming out of the speaker. So that tells me that the driver is probably okay. So there's the square wave changing duty cycle. There's lower volume. So if you look very closely, right down here it says max 1.82 volts. So that's the DC average. So it is running at 40 kilohertz right there, and we have a 2 volt peak-to-peak signal. So this might help me troubleshooting the other unit. I think this has a preamp problem, and the power amp is probably okay, because I do believe it was doing the exact same thing on the other amplifier. It was just basically distorting and clipping like this, but at least the low-level board, the preamp board on this one, does successfully power up this amplifier, which I believe is okay. We're still chasing down a unsuccessful power up on the SuperCube 3 low-level preamp board. Alright, so I've got this powered up back again, and I wanted to look at one thing right here. Here's the modulator output to that. It's called PMA right there. And all it is basically, there's a basically a comparator right here, and it just turns this transistor on or off, and so it should pull it up to about 15 volts and then down to, well, effectively 0. And it's pulling it down to like 0.7 of a volt. So I'm going to say that the preamp on this unit is working perfectly, and that we do have a problem in the power amp in addition to the SuperCube 3 preamp. This is the 2 that I currently have hooked up, and it is allowing the power amp to successfully power on, but I believe that this is working normally, and we do have an issue with this power amp, which is why it's humming. Maybe it's got high ESR caps right here. I should go ahead and check those, I guess, and just see what's going on. I haven't changed the 4 caps over here yet. I do need to do that. I don't think they're that far out of tolerance. Maybe we've got a case of the conductive glue etching a trace away. So I guess I need to go ahead and measure the voltages over here on the regulator and on these caps right there and see what they have to say. We still have an issue with the SuperCube 3 preamp, which needs to be addressed because it will not allow the main board to successfully power on. Okay, so here is the waveform of the customer's low-level preamp board on the SuperCube 3, and it looks perfectly fine. I've got virtually the same waveform, very close to the same frequency. The other one was 40 kilohertz. This is 36. So at this point, I do believe that we have probably 2 issues, one with the power amp and one with the preamp, because it is still not outputting that signal to the what's called speaker relay terminal to turn on the power amp and the LED. So watch this as I gradually increase the volume. I see the duty cycle is changing, so that tells me the majority of the preamplifier board, and especially this pot, is working. I don't think we're looking at a pot issue at this time. I still could be wrong. I'd hate to go this far into it and determine, yeah, it's just a freaking pot that's bad. I don't think that's what's going on. I think something else happened to this unit. So as you can see, I've got a virtually perfect 50-50 duty cycle right there. And as I add volume, you can see the duty cycle does change as it increases or decreases basically the base to the power amplifier circuit. So I need to figure out what is going on with this thing. Why is it not powering up? And yeah, another SuperCube that's going to tax my troubleshooting skills if I can even figure this thing out. Who knows? Okay, it might be kind of hard to see, but I did drag out my 117. This one does have the low impedance mode, which puts a 3000 ohm load on the circuit. So what I'm going to do is attach this to the speaker relay terminal, and it's going to basically simulate that this amplifier has commanded the power amplifier on. And look at that. I show 14.3 volts. It's working. It is actually working. So I know the power amplifier is good. Once I remove that, the power shuts off. As soon as I attach it, we get audio output once again. It's going into clipping. So there's definitely something else going on with this board in the auto power on stage. I'm not sure what it is. I'm not sure if I can fix it because the schematic that I have does not match the actual circuit board because this appears to be a later model circuit. Anyhow, that's where we are, and that's part 2 of the Definitive Technology Powerfield SuperCube 3. Okay, so I thought before I throw in the towel on this thing and just say, I don't know what's going on, I'm going to check some of these little surface mount caps. Of course, and you shut down. Thank you very much. So we'll zero those out. So 0.0 is what I should get. If I can keep them touched together. Yes. So here is a 100 microfarad cap. I see 0.98. I'm okay with that. Another 100. 0.74. Good with that. This one might be hard to get. 6 ohms? Oh, no. Bad. This is a 10. I'd like to see probably maybe 5 ohms. And it is open. Hopefully you can still see me. This is another 10. And open. Here's another 10. Open. Another 10. And it is open. What is going on with this thing? So here is a 22. And it is open. Another 100. 1.2. Okay. I doubt I can't get my probe on that one. Way over here, kind of hard to see off camera, probably under some stuff, is another 22, and it is open. And I can't get my probe on this other 22 that lives right there. I'm going to bet it's open as well. So at this point, I'm going to go ahead and I think give my customer a fairly accurate estimate. I'm surprised this thing even worked at all when I shorted the power supply to the on mode. So replace all 3 of those caps. I'm sorry, all 3 of those pots, as well as recap the entire low-level circuit board. And I do believe the high-level board's good, but like I said, I'm going to change a couple of the parts on that board just to be safe. High failure items, a couple power supply filter caps, and those 4 caps on the FETs, the Class D digital amplifier. So I think I am at a place where I could give an accurate estimate to this customer, and I feel pretty good that replacing these caps is probably going to repair the issue with this unit. I guess we'll find out if he wants to approve it. It's going to be a few hours and some parts, so it's probably going to be a couple $100. We'll see what he wants to do. Anyhow, that's going to end part 2, the diagnosis portion on this Definitive Technology Powerfield SuperCube 3. Anyhow, I certainly hope you enjoyed this video. Go ahead and leave me a question, a comment, a concern down below, good or bad. I do try to respond to the comments when I have time, which hasn't been that much lately, but I am trying to get caught up. Remember, you can follow me on social media, Facebook, Instagram, Twitter at NorCal715. You can email me, NorCal715videos@gmail.com. That is the best way to contact me. Once again, please be patient. I have a full-time job, and I do these repairs in my spare time, and I'm still several months behind because of this accident. And incidentally, I did remove the jumpers and add 1K resistors just in case this thing wanted to find the pot somewhere in the middle. And still nothing. I believe it was those capacitors that is causing the problem. If you do email me, if you do try to contact me on Facebook, Instagram, or Twitter, please be aware I never check those messages. Please email me and be very, very patient using the Gmail address only. Remember, with your help, we can try to keep these things out of the landfill, out of the recycle bin, and out of the e-waste facility. Everyone, thank you for making it to the end of this very convoluted multi-part diagnostic video. I really do appreciate it. Everyone have a great day. Once again, thank you so much for watching. Bye-bye.